Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find x? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Look at quadrilateral ABCD. The side BC, drawn in red, is marked x, and finding that length is the whole task. Every other measurement in the figure is placed to pin it down. Three sides are each 2 units long. Segment AB, segment AD, and segment CD all equal 2. Keeping these three equal lengths in view is what will let the pieces of the figure lock together later. Two angles are given. The corner at A, angle BAD, is a right angle, and the corner at B, angle ABC, measures 75 degrees. These two facts will drive the entire solution. The vertex C sits off on a slant, so segment BC is hard to reach directly. The clean move is to connect B to D, splitting the quadrilateral into a triangle we fully understand and a second triangle that carries the unknown. Draw the diagonal BD. Because segment AB and segment AD are equal with a right angle between them, triangle ABD is a right isosceles triangle whose two legs are both 2, and that is a triangle we can measure completely. Because the right angle sits at A, the diagonal BD is the hypotenuse of triangle ABD. The Pythagorean theorem says its square equals the sum of the squares of the two legs. Put in the two known legs. 2 squared plus 2 squared is 4 plus 4, so segment BD squared equals 8. One more step turns this into the length itself. Take the square root of 8. Since 8 is 4 times 2, the root simplifies to 2 root 2, so the diagonal BD is 2 root 2. This length feeds the second triangle. The angles of triangle ABD add to 180 degrees. The right angle at A uses 90 of them, so the other two base angles together must fill the remaining 90. Aha! Triangle ABD is right isosceles, so it gives two facts at once. Diagonal BD is 2 root 2, and angle ABD is 45 degrees. That length and angle pair is exactly what the remaining triangle needs. The 75-degree corner at B is built from angle ABD plus angle DBC. Subtracting the 45 we found leaves angle DBC equal to 30 degrees, and that angle lives in the triangle, holding our unknown. Now turn to triangle DBC. We know the side BD, the 30-degree angle at B, and the side DC. But segment BC is slanted, so we cannot read it off directly. A height will straighten things out. Drop a perpendicular from D straight onto side BC and call the foot F. This new point F carves triangle DBC into two right triangles that share the height segment DF. And right triangles are easy to measure. In right triangle BDF, the height segment DF is the side opposite the 30-degree angle, and segment BD is the hypotenuse. So segment DF equals segment BD times the sine of 30 degrees. The sine of 30 degrees is 1/2, so segment DF is 2 root 2 times 1/2, which is the square root of 2. Hold on to this height. It also feeds the other right triangle. The base segment BF of that same right triangle lies next to the 30-degree angle, so it is the hypotenuse times the cosine. That gives segment BF equals segment BD times the cosine of 30 degrees. The cosine of 30 degrees is root 3 over 2, so segment BF is 2 root 2 times root 3 over 2. The 2's cancel, and the roots multiply to root 6, so segment BF is the square root of 6. Aha! Segment DF is one shared altitude for two right triangles. In triangle BDF, it converts the 30-degree angle into the piece segment BF. In triangle DFC, the same green height turns segment CD into the remaining piece segment FC. The two pieces can then rejoin along segment BC. In a right triangle, the leg squared equals the hypotenuse squared minus the other leg squared. So segment FC squared is segment CD squared minus segment DF squared, which we can now fill in with numbers. Segment CD squared is 4, and segment DF squared is 2. So segment FC squared is 4 minus 2, which is 2. Taking the square root gives segment FC equal to the square root of 2. The foot F lies on segment BC between its two endpoints, so the whole side is simply the sum of its two pieces. That means segment BC equals segment BF plus segment FC. Add the pieces. Root 6 plus root 2 is the length of segment BC, and since these roots are unlike, they do not combine any further. So this sum is the exact answer. Therefore, segment BC, the red target X, equals square root of 2 plus square root of 6. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.